So today we will be looking at data importation and how we can actually export or write or export data from R. So why the objectives of this module will be, first of all, it will be good, first of all, we know what are the different types of data formats that we are likely to encounter in our research or in health research, okay? How do you actually deal with different kind of formats that that you encounter in our day-to-day lives in health research? So the other objective will be, how are these different formats read into R for further processing? Because as we had alluded earlier, is that the reason why we are learning R is that at some point we may be able to post-process some of the data, be it that this data has been obtained from the routine clinical visits by patients, be it data that has been obtained from administration of drugs. You may want to see, or you may wish to actually have a view as to how many patients are using this kind of drugs and etc. So it's important, first of all, even if that data was entered in a different, maybe be it was entered in Excel, in a different database, but now as an analyst or as a person in health research, how can I analyze that data? Okay, so we'll look at how we can actually read different kinds of file formats into R. Then once we are in R now, we have been able to analyze that data. We have been able to manipulate that data according to the objectives that we have. Now, once you're actually done with the processing of that data, and you wish maybe to again write what you have, that new file that you've obtained, or that new data that you've obtained, how do you actually write it into files while you are in the R environment, okay? Then the other objective will be to use different packages that we think will lessen the effort required in reading and writing some of these files, okay? Now we know that in health research, as I've mentioned just a few moments ago, is that depending on the source, depending on the curation or the storage requirements, you may actually find that some data take different forms depending on the storage requirements, okay? I will not expect that in the course of your work, if you have a data set that has over, just for example, something like over 1.5 million entries, I will not expect you to be using Excel. Excel will also have its limitation, okay? Thereby, that may force you to use a different data format, for example, okay? So for the purpose of this training, maybe we can look at these formats. We can have .xlsx, that is when that data that you're dealing with was actually keyed in or was entered in Microsoft Excel. There's this other format which is called .rds. We'll talk about .rds later, because this is what we call an R data file. There's a way R also formats the information or the data which is in its space or in its workspace, and it is possible as a user to save this .rds data, and we'll see what are the advantages of saving information in R in .rds file, okay? Then we will look at TSV. We can also look at .csv. These are comma separated values. And so we also have another issue that in some cases, some of this data can be stored in what we call a text file. That is a .txt file, and I know so some of us may have actually used Notepad in our day-to-day lives. Okay, that Notepad, the default extension for saving files from Notepad is normally .txt. Okay, and it's possible to actually write data into a text file, but that is just I mentioned that in some cases people can use text files, but also there's a point in this slide where I'm saying that text data files will not be covered in this training because text data files, they normally have limitations in that they may not be able to handle large data sets. Okay, they may not be able to handle large data sets. So now let's see. Now R provides, or the R Studio interface provides us with so many ways that that we can load data into the workspace. Okay, and it is so versatile that you not believe that you can load data from Excel, you can load data from Stata, you can load data from SPSS, you can load data from SAS, and you can load data from Microsoft Access. I mean, you can actually load. I can say that you can load so many extensions of or so many data formats can be loaded into RStudio. Okay. So now, as I mentioned earlier, uh, uh, the aim or one of the objectives for this module is to actually see what are the strategies in R can we use to actually load our data. Okay, and maybe before we proceed, the reason why we may need to load data is, as I've said, that this data may have been keyed in some other areas. Okay, maybe be it in research, be it in your clinical environment, be it from surveys and etc. Now, coming to actually defining that data into the R script, that becomes cumbersome, and it's not really realistic when you have so much information that needs to be fed into R. That's why we think that it is always recommended or advisable that to first of all just have this data in a specific format, then you can import it into R and work on it in the R environment. Okay, so these are the strategies that we will look at. How do we import different data formats? Okay. Now, before we proceed, I would just like to share this screen here. This screen here, you can see it's a .txt. It's a .txt file. So I would like you for those who are actually using Windows or Mac, you can just open a text file, an empty text file. You can fill in that row number 1 is height. Then you put a space, weight, put a space, age. Then you can put for the height, the 60, 61, 63, 64 up to 67. Then also for the weight, 120 up to 146. Then for the age, 37 up to 34. So this is just a sample data that is in the TXT. But I would like us first of all, we start to understand if we have such a data, how can we import it? So we can just take a minute or two. You can just quickly type this in your text file or a notepad, then save it as maybe age_weight.txt, but you're at liberty to choose any name, but the extension has to be .txt. Okay, just for a minute or two, then we can proceed to the strategies of importing that data into the R workspace. So is it visible enough? The what I'm sharing, this text file?
Yes, we can see it.
Oh, okay, perfect. Thank you. Thank you, Frank. So it's just a simple text file, but as we proceed, we'll actually move on to more comprehensive data sets that we can be able to use the techniques that we'll be learning as we proceed. So, and this was just a random population of that data. So which is 60 centimeters and a weight of 146. Maybe that may not make much sense, but it's just a simple, just for illustration. So, and please remember, between the height and weight, you put a space. Between the weight and age, you have to put a space. And also between those values for each and every row, you put a space. So it will be 60 space 120 space 37. That is for the second row, and etc. up to the 8th row. Okay. And oh yeah, oh yes, Frank, you can actually put the file here, or just send it to everyone. That will even be easier. Thank you, Frank. Okay, as Frank has said that he will be sending that file to you. So please make sure that you save it in a folder whereby we will also open a script, an R script, where we'll also, the R script and that .txt file, let us put them first for this session. Let us put them in one folder, okay? Let us just put them in one folder. So I see Frank has shared that data set, that sample data set in your chat. You can download it, and you can download it and save it in a given folder. And in that folder, as I've said, we'll also open an R script for today's session, and also make sure that that R script is saved in that same folder where that file is.
Duncan, I've only
Yes.
shared the .txt file. Did you
Yes.
want me to share the R file as well?
Uh,
I think the text only.
yes, just the TXT only.
Okay.
Yes, just for now. Thank you, Frank. Okay, so now I will assume that we have all downloaded that file and saved it somewhere that we can quickly access it. So and sorry for this this PS that will not use text data files. I'll just use it for illustration. Then for the next session, we'll look at a different, a more comprehensive data set. Okay. So here we've said that we'll look at several strategies that can be used to import data into R. But if we go to the R environment, you can see that in this part here, if you can see my screen, where there is environment, there is history, there's connection, tutorial, and viewer. Just below history, there is that import data set that has a drop down. So if you click on that drop down, you can see that there are options which has been given to us on how we can import data or where we can import that data. There's one which says that we can import text, but now we will use the base R functionalities. There's also another option for reading from a text file, but that one will use the package readr. This one we'll look at it later. Then there's also an option of reading from Excel, SPSS, SAS, Stata, and etc. Okay. So I would like us, so if we come to the import data set, just click on that drop down and let's use the first one. That is from text base. You can click it, and once you click it, it will prompt you to actually go to where you have saved that .txt file. So for that matter, I think mine, I saved it in a folder which is called a class session. I can access it, so I can select it and click open. Okay. So now the beauty about using the import dataset tab is that there are some options. You are actually given an option to select some of the options which will come. We will see later how they can be defined in a script. For example, there's the heading. You're actually being asked whether this data set has a heading. Okay. And automatically it has been set to default to be yes. You also have row names. Row names, it has been given to be automatic. There's a separator, which is the white space. For our case, remember that data set, we were using spaces between the row names and between the columns. We were using a space between them, or a white space. Then there's also an option how if you have values in that data, do you want them to be the decimal point to be a period or a comma? Because some of the European countries, they use a comma for decimal points. Okay. Now the good thing again, it actually gives you an option to actually preview the data that you have. So you can see that just here on your right hand side, you have the input file. Then below the input file, there's that box there which has what is called a data frame. Okay. Remember, I said that the heading has already been chosen for us as yes. But let's see what happens if I am to choose the option no. If I'm to choose the option no, I can see the preview in that data frame now has another row which is given in terms of V1, V2, and V3. Okay. So what R does when you're importing a data set, if that heading equals to false or a heading equals to no, what R does, it assigns headers in that file. And it will assign headers in this way. It will assign headers by having a letter capital V followed by the number of that column. Like in this case, it will take V1 because that is the first column, V, then 2, V3, and etc. Okay. But now, since we are saying that our header is yes, then in the preview, you can see the V1, V2, and V3 they have disappeared. Okay. And if you're satisfied with our option and what we're actually previewing in this box, which has the title of the data frame, then we can now click import. Once you click import, it means that that ageweight.txt, that data file has been imported into your workspace, okay, or the environment. Now, what has actually happened is that if you see the information which is being passed in that console, it means that R has used a function which is called read.csv. Okay, it has used a function which is called read.csv, and for that matter, where is that file? So what it has done, it has actually automatically taken the path of where that file is, plus the name of the file and its extension. Okay, and remember, we had also selected an option that we wanted that the separation between the different characters to be a white space. So it has actually given us that option there. Okay, that's what has happened. But we'll see more about these options shortly. Then it has automatically again done the view for us. Remember what Ashna was showing us about that if you want to view given information or given data which has been loaded, you can just write view in your script. For example, we just write view and the name of our data set is age underscore weight. And since that data set has already been loaded into an environment, you can see also R is actually suggesting for me what names it might be. So I need to select that. And once I run that, it opens for me that data set. Okay. Alternatively, how I can actually view, I can just come to my environment and double click on this age weight. If I double click, again, that's also another way of viewing that data. Okay. So what has actually happened? It's also giving me a summary whereby it's saying that there are 7 observations, and each of them has 3 variables. And it's true because our data set had height, weight, age, and the entries were 7. Okay, the entries were 7. So that is one way we can actually use that import dataset tab on our RStudio to import data. Okay, now we can say that this data has actually been loaded into our R environment. And it's true because if you have actually seen, when I've said view in this R script, and on running this R script here, you can see that it has executed that view age weight. So it means that that dataset has already been loaded into our environment. Now, what has that import done again? It has executed the view for that age weight, and that's why we are actually able to view that age weight file on your left hand side. It has also used what we call, if you look at the console, it has also used what is called the read.csv. So it has read that file using the function read.csv. Okay. But the next argument in that function is where is that data file. Okay. So it has taken the path of where that data file is stored and had it as an input argument. Okay. The other option is that it has also given us the option of a separator, which is called the sep. And for this case, in the sep, we actually picked a white space. So you can see that it's sep equals to double quotation and there's nothing inside. So it means that is a white space. Okay, that is what is done. But this is something that we'll look at in our next slide. Okay. Now, how can we confirm that the data has been loaded into our environment? The first thing is that it appears in our environment here, which if I double click, I can be able to view the elements in that data set. Okay. The other thing is that in my, I can just open an R script. So how do you open the R script? Let us just come here. I can just come here and say open, that's a new, and I open an R script. Then I want to view, because I'm aware now this age weight has been loaded into my environment. I can just say view. And if I type age, because that data set has already been loaded into the environment, R will suggest it for me and say, oh, there's a file which is called, there's a data set which is called age weight. Is this what you're looking for? I just need to press enter and run that line. I can just come here and press run, okay? And you can see it has also done the view for me again, okay? So two ways you can view that data. You can use the function view into bracket the name of that data set, or you can just come into your environment and double click on that data, okay? Now let us look at what are the other options which exists when you want to, what are the other options which exist when you want to import data? So the first function or the first command that we are going to use is what is called read.table, okay? Read.table. The first strategy I've seen is when we are using the tabs on the R in the R Studio. Now let us look at how we can do the scripting and import data. So there's this function which is called read table, and we say that this is actually the most commonly used function for reading data. Okay. The other point is that it will read data as a data frame. Okay. Now, the default for read table is that, do you remember what we talked about, the separator? Now, for the read table, the default is always what you're calling space delimited. The separator for read table is always space, okay? In previous versions, if you specified a separator differently, read table used to fail. But now that has been addressed in the current versions of R, okay? That is read table. So we are going to use a read table. And remember, we now continue working on our R script, okay? We read table. So in this case, we have, for example, if a file called ageweight.txt is read using read.table, it's read using read.table as follows, okay? So what do you want to do? We come back to our script. Sorry. We come back to our script here. Okay, I can call the, let me save this script, this R script. I can call it as, and I save it in the same folder where the age weight.txt file is. So you can call it data, just a name, data session, maybe class or something like that, and I save it. Now this is a script which I've opened, and I have saved it in the same folder where my age weight.txt is stored. Okay. What do I want to do? I want to read, first of all, I will assign, maybe I can call this age weight reading. Okay. But what do I want to do? I want to use the read table, read.table, and you can see the moment I've just written read.table, it has given me an option and say that, oh, there's these different files which exist, and the ones and on the far right hand side, if my cursor is active on the read.table, we can see that it has given me all the options that will actually go into that function as arguments. We can see there is file. So this file, I'll have to give it the name of that file. There's the header, there's the separator, there's the decimal, and etc. All these options, okay, some of these options, we were able to actually define them when we were importing data using the first strategy, okay? But when you're using read table, these are options you have now to declare them explicitly in that argument. Sorry, as arguments. So because I'm interested in the first one, which is the read table, I can click that read table. Okay. Then now there are arguments I need to do. Okay. What is the first argument? Since I am in this script is in the same folder as that file, I can just give the name of that file. And I'm supposed to encapsulate it in the double quotation marks. So what is the name of the file? It's age underscore weight dot txt. Is it? That's it. I can save that that R script and I can run it. Okay. So and remember, I've given it the name age weight reading. I've just assigned that when you import that data, give it the name age weight reading. No such file. Okay. Then what we can do, we can just give it the whole path. And we see. Yes. So what was actually missing was that I was supposed to give the whole path where that ageweight.txt is. So you can see it's in the folder which is called the class session, and that class session it's in my desktop, it's in my users DKG and etc. So now, by just doing the read table in my environment, you can see there's that age weight reading, and it has 8 observations with 3 variables. Let us view it. I can come and say,
And Duncan,
yes,
if I can ask a question, while
yes,
you're
please.
still on reading the file, I
Mhm.
see you have used the sign left-sided arrow.
Mhm.
Can someone just use the assignment operator
Mhm.
instead of the arrow, and would it still work the same way?
I actually think I have a confession.
Mhm.
I loaded another font into my computer, and
Mhm.
you may find that in the R environment, this font is not there. So I can just show of anyone who is interested. There's general appearance. You can see on this other side, the default one is the less than and a hyphen. Okay,
I see.
but the font which I use is called the JetBrains Mono Light, and maybe it is the one which actually converts that less than hyphen to be this. Maybe.
Super.
Yeah. Okay.
Thank you.
Yeah. No worries. So now, let us view our data now. We have already loaded it. So, and it has suggested for me that it's age, weight, and reading. So if we run that line, we can see that, oh, there is V1, V2, and V3, which has been added. Okay. You can see that we are saying that now we need to add that option of header equals to true. Okay. Because we already have our header row and we want it to remain the way we had defined it. Okay. So let's go back and add that option. So let's go back again and add that option to our script. Sorry, guys. Let's come and add that option. After here, we just say a header, and you can see once you type head, it suggests for you the completion. Let us say it is true. True for yes. Okay, let's run this again. Now you can see automatically in my environment, the observations have reduced to 7. Okay, which means that if we are to view, if we view it, you can see that V1, V2, and V3, that one has already disappeared. Okay, so now we are left with our data the way it was, okay, or the way that we want it to be. Now, that is a read table. Read table, and using the option of header equals to true, so that we can have the headers of our file the way we had defined it in that table. Okay. Now, some of the options which are used as arguments in the read.table function is something like header equals to true, the one that we have just used. Okay. There's also the sep equals to. There are those two quotations, so you can decide whether it's a space, is a comma, is a tab, okay, or is a semicolon. Those are options that can be chosen. There's also an option of row names. Okay, you can define some row names as well. There's also a question of deciding what character will be used for the decimal points. Is it a comma? Is it a period? All those are options that you can actually use. You can actually use them. Okay. So still on our read dot table, we can add some of these options. Okay. Though for our case, maybe the decimal will not make much sense because we can see that for our case it is these are whole numbers, so we actually don't have even a decimal point. So this is actually, it's not even required for our case here. Okay, but now we can have what we call the row.names, which is an option. If this option is selected to be null, what it does, it forces row numbering. Okay, it forces row numbering. That's one thing. The other thing is that we can also decide that there's a way we want our rows to be. We can enforce our own row names if we wish. So let's see. So if we go back to, so we say that this one is just a period, though it will not be used. And remember, for the arguments in the function of read.table, they are separated by a comma. You can see the path or where the file is. Once that has been done, there's a comma. The next argument is header equals to true. There's a comma. The decimal point, we also have to put a comma. Okay. What other thing do we need? We have said that the row names, row.names, we have said to be equals to null. Okay, equals to null. What happens if we run this? What happens if we run this? We've said that as long as it is null, it enforces numbering of the rows. And you can see when you view it, there is this 1, 2, 3 up to 7. But that also happens to be the default selection of that argument. It will number the rows for you. Okay. Now, let us copy what we have here so that we can create another data set from that same file. But I want us, instead of using the row numbers, let us give it names. Okay. Like what we have here is that I was saying that instead of having the rows as 1, 2, 3, 4, 5 up to 7, let us give them the names 1, 2, 3, 4 up to 7. Okay, and we see and we see what will actually happen there. So in this case, let us so it is 1, 2, 3. Let me remove that. Let me remove that bracket. Okay, let's give it a new name, maybe age weight reading row names, something like that, so that it's a different data set. So if we run this, you can see that in our environment, we now have a new data set, which is called age weight reading row names. Okay. If we view this, you can see it is giving me I have two options. The first one, we want the second one. And I run that. You can see that what was formerly 1, 2, 3, 4, 5, 6, and 7. Now we have actually given it in terms of the names there. Okay. And this can also be done for columns as well. Since we have 3 columns, instead of having height, weight, and age, you can also decide to even change those names. Maybe you want to name it height of a person, weight of a person, and maybe the age of a person. You are allowed to do that. And you can do that if you use this call.names. Okay, call.names. You're allowed to do that. So those are just part of the options that can go in as arguments in the read.table function for importing data into our R environment. Okay, I have given a link there that is at the footnote there, whereby there's a whole list of options which are there for the read.table, but using the header, the separator, the row names, row.names, call.names, and the deck. These are the mostly used options when you're using the read.table, and I believe with those ones you'll be able to import your data in any way that you wish. Okay. I don't know whether there's any question as far as read table is concerned. Now, moving forward now, there are also other functions that are used to import data. But what you'll notice is that the syntax is almost the same. And most of the arguments that goes into that function is almost the same. The only different thing is that it will be file format specific. Okay. Like this next function that we are going to look at, it is what is called the read.csv function. Okay. This one, we also say it's a derivative of the read.table function. So it's what people call a subset of the read.table function. And in that, this one is it is made to import data that have comma separated values. Okay. And when I talk about comma separated values, it means that that SEP option or that SEP argument, what goes there is actually a comma. Okay. So it is used to read comma separated values. Okay. That is, so we'll look also at one of the read.csv files. And you can see the options are almost the same, because this file, I can either give the name of the file if you're working, or the path where that data set is. Again, the option of having the header equals to true, we wanted to use the header that is defined in that data set. The separators or the value separator is a comma, and you can also have the option of defining it as the decimal points as a period. Okay. Now, another version of read.csv that exists is what we call the read.csv2. The difference between the read.csv and the read.csv2 is only the separator. The read.csv, this one reads comma separated values. That is a sep is a comma, while the read.csv2, the separator is a semicolon. Okay, is a semicolon. Okay, I hope that's okay. Then we can also have another what is called read.delim, which is a function. This one now, the only difference with the other one is that this one reads tab separated values. Okay, if you're keying in that data in a .txt file, and let's say height, you type tab, weight, tab, and age like that, then it would be better for you to read that using the read.delim function. Okay. And there's also another version which is called read.delim2. The difference between read.delim and read.delim2 is that read.delim, that one uses the decimals. They use a comma. Sorry, they use a period. Okay. But for read.delim2, they use a comma. That's the only difference. Okay. So all these, the read CSV, read CSV2, read.delim, read.delim2, all these are just some small tweaks in the arguments, and they have been made that so that it caters for all permutations of the data that one may have. Somebody may have one which is tab separated. There's an option for you to read that data. Somebody else may have one where the decimal, it's tab separated, but it has a period for the decimal. Then you can use read.delim. Okay, read.delim2 is when those decimal points are separated by, for the decimal points, we use a comma. Okay. So let me, I can see this. Okay, thanks, Falcon. I don't know whether there's any question up to that point. Okay, I know there's something that I mentioned earlier. When we used the import dataset tab, I showed you that that R read that file using the read.csv. Okay, let us do it again. So if I come again and text base, I go to my class session, edge weight, and open. So that's the option that we have, and import. You can see here in my console, what R has done is that, let me just copy what is in the console. What R has done is that it has used the read.csv function to read that. Okay, so let's call this age, maybe reading CSV, something like that. Okay, let us run it. So if we run it, we can see that it has been added in our environment. So if I double click it, that is the data. Okay, that is the data. But what has been used here is read.csv, and because we had chosen in our option that the separator will be space, that is what has happened. It's given us that our option was this one. We can also add this one, though it's not being used. Our data set will still be loaded. Okay, I think we can just do it practically here. So there's that read.csv. Let us just use that separator as. Let us remove the decimal one. So we just have that the separator is like that. Do you see what has happened? Is that the formatting now is also different. The formatting is also different. So what is actually recommended is that if you know that the data that you have is tab separated, just read it using the functions which allow reading of the tab. Okay, that allows reading of that file with the separator as the tab. Okay, if you have if you know that your data is separated by space, there's a wide range of options which can read that for you. And one of them is the read table. Okay. So what I can say, like the first thing for Eric is that, first of all, just have an idea. How has the data been separated in that? Okay. Number two, if in the event that you are not sure of how the separation has been done, you can always use the read table. Read table is the commonly used one because it's not that targeted towards a specific format of that data. So read table will always work for you, devoid of you knowing what separation was used in that data. Okay.
And there is another question from Ludovic.
Okay. Okay.
He's asking, what is the advantage of using any of these read functions over the manual importation through the import dataset?
The advantage. I think that the advantage of using these read functions is that if I actually come here, let us do that again. If I come here to import dataset, I can see that I have Excel, SPSS, SAS, and Stata. Okay. Now, what happens for example, let me just close this. Let me close this viewing. So now, Ludovic, for example, now I have this script here where I'm loading the data using the functions. Okay. Now, suppose I close my RStudio and I don't save the data, or what we'll look at later, which is called .r data. It means that whatever data that was in my environment, I'll not be able to access it when I reopen my RStudio. Okay. So the reason, or in a nutshell, what I can say, using functions, it isn't reusability of importation of those data sets. And like, do you imagine if you have a number of data sets, each and every time, if you have about 5 data sets, do you imagine importing each and every one of them manually each and every time that you open R? While if I use functions actually lessen or isn't uploading and importation of those data, because what I have to do, I just have to open my my R script and run it, and it imports for me all that data depending on how I had defined them. Okay. So I can actually say reusability is enabled when you use the functions in an R script. And to some extent, it also allows it allows the process of automation, for example. Yes. I don't know whether Eric, no, Ludovic, I don't know whether that answers your question. Okay, okay, wonderful, wonderful. Okay, so let's see what comes after that. Read the limb. And the other thing is that you can also import data from websites and URLs. Okay. So, but what is the function that is used in this case is what we call the read.table. But now, what you have to do, like in line 1, you just have to define where that URL is. Okay, URL or the link to that data. Once you copy that link and come and paste it here and define it as your URL, then you're ready to go. You can just use a read.table function. So read.table function is actually a very powerful function, and that's why it's one of the commonly used functions in importation of data. Okay. So maybe I can preempt this from our next session, is that R, the R framework also has one which is called the RDS or .rds, where it actually stores a single R object as a data frame. And why is this important? Is because there is a way R structures that data, and .rds enables R to store that clean data and maintain the column classes or how the columns were structured. Okay. The other advantage of saving or having an R data file is that this R data file also saves the complete workspace. Do you remember what I was talking about, that if one actually clears the workspace, next time you come, you may find that the data that you're using is not there if it not save the .r data. Okay. Now, if you save the .r data, even if you close or shut down your RStudio, when you come and open next time, as long as you saved the .r data, it will actually load for you the data set that you are using previously. Let's say, for example, and it's because, for example, I want to close this this RStudio window. So if I want to close, let me just show you. If I want to close, you will see it will actually prompt me to save what is called the .r data. You can see this one, the first option there, and it's what is called the workspace image. It will prompt me to save that. If I save it and open RStudio next time, I will be able to see the data sets which were loaded in my environment in my previous working. Okay, so that is the one of the advantages of saving the data as .rds. Okay, .rds. So why is this data importation and data exportation important? Because we can work with our input data, be it in .csv, be it in XLSX from spreadsheets, .rds. We do everything that we want in R and also export it the way we want. We can also export it in .csv, .xls, and etc. Okay, after we are done with our analysis in R. So that's why this is important. Okay. So I think we are almost at the top of the hour. So maybe I stop there for today. Okay, thanks so much, and I'll see you next week. We'll also look at the Rio package, as Frank has mentioned, which may be a bit easier to use than the others, but we'll see.